Today I'm going to be talking about the difference between average speed and average velocity and looking at a few problems dealing with these differences. Average velocity is defined as the ratio of the displacement to the time. The way it's normally written is x2 minus x1 divided by t2 minus t1. Although sometimes students have a little bit of trouble with this definition, the t2 is referring to the stopwatch reading when the object is at position x2, and the T1 refers to the stopwatch reading when the object is at position x1. Again, it's important that you don't just take two times that are given in a problem and just automatically subtract those. You need to think about, if you start a stopwatch at the beginning of the motion, what does the stopwatch read at the different points in the motion? Average velocity is something that can be positive or negative when we're looking at one dimension. But in one dimension, the positive for average velocity will mean that it's moving in the positive x direction. It means that the final position is bigger than the earlier position. If the average velocity is negative, it means that the object moved in the negative x direction. It means that the final position is smaller. Average speed is the ratio of the total distance divided by the time. Average speed is something that does not depend on what direction you're traveling. To find the average speed, you just go through and you add up all of the distances to get the total distance, not worrying about what direction they're in, and you take that total distance and you divide by the total time of travel. In these next few problems, we're going to be looking at the difference between average speed and average velocity for an object that's moving along. So in this problem, we have an object that's moving along the x-axis, and it's going from point A to point D to point C. And that takes 28 seconds. And we want to calculate the average velocity over the entire trip. So again, the definition of average velocity is the displacement x2 minus x1 divided by the time interval. And so the object is starting when t equals 0, and so when it reaches point C, the stopwatch is going to read 28 seconds. So the time interval that we're looking at here is 28 seconds. And from this, we need to look at the displacement. So our final position is the position at point C, which is 2 meters. And we subtract from that the position when we were at point A, which is negative 5 meters. And the time interval, again, is 28 seconds. Again, it's 28 seconds at the end minus 0 seconds at the beginning. And so this will be 7 meters divided by 28 seconds, which will be 0.25 meters per second. One of the things that you notice is that the fact that we went to point D has no effect on the average velocity in the calculation. Now, the fact that we went to point D, it increases the time that this takes, but nowhere in the calculation do we include anything about point D. We just look at point C, and we look at the starting point, point A, and we calculate the average velocity to go between those 2 points. What this average velocity really is saying is, if I started at A and went directly to C without going anywhere else, I would need to travel at 0.25 meters per second to make it there in 28 seconds. That's what this average velocity is giving us. In this next problem, we again have the object starting from point A and then going to point D and then back to point C, again in 28 seconds. So when we start, the time is 0. When we end, the time is 28 seconds. But this time, instead of finding the average velocity, we're finding the average speed over the entire trip. So the average speed is the distance divided by the time, the total distance divided by the time. And when we're going to calculate average speed, we need to add up all of the distances. So when I go from A to D, I'm going from negative 5 meters to 5 meters. That's a distance of 10 meters. And when I'm going from D to C, I'm going back 3 meters, so that's a distance of 3 meters. And so this average speed is going to be the total distance of 10 meters plus 3 meters over 28 seconds, or that's 13 meters divided by 28 seconds, which is an average speed of 0.4643 meters per second. Now, some people might be wondering, this is exactly the same motion we looked at in the other slide. We went from A to D to C, the same points in 28 seconds. In the previous example, we got 0.25 meters per second for the average velocity. This, we're getting 0.4643 meters per second. And this is because this does specifically take into account the fact that going from A to D to C is farther than just going from A to C. The last one, it only depended on the displacement. We only cared about the change in position. We didn't care where we went in between. And so this takes into account all of our motion, no matter what direction we were traveling. The other one, if motion is to the right or to the left, sometimes those motions balance each other out. In this next example, we have the same number line, but we have an object moving between different points. So this time, it's moving from C to D, and then it's moving from D back to point A. And it says that this takes 35 seconds. So again, that means that when it starts at point C, the stopwatch reads 0 seconds. And in the end, when it reaches point A, the stopwatch is going to read 35 seconds. So again, the definition of average velocity is the displacement, x2 minus x1, divided by the time interval. So this, x2, is the later position. That's the position when we're at point A, which is negative 5 meters, minus the position at point C, which is positive 2 meters. And that's divided by the time interval, t2 minus t1, which is 35 seconds. And if I wanted to write that with the subtraction, it's 35 seconds minus 0 seconds. Again, you're subtracting the stopwatch readings when it's at those two positions. And so this gives me a displacement of negative 7 meters divided by 35 seconds, which is an average velocity of negative 0.2 meters per second. This negative sign here means that the object moved to the left in the negative x direction. So again, average velocities are vectors. They have a magnitude and they have a direction. And in one dimension, that direction is represented with a positive or negative sign. Positive meaning in the positive x direction, or the positive y direction if we have something moving vertically, or negative sign meaning that it's in the negative x direction. In this last example, with something moving along a number line, we have an object going from A to C, then to D, then back to point A. And this takes 18 seconds. So when we start at A, the stopwatch reads 0 seconds. And then when we end up back at A, the stopwatch is going to read 18 seconds. So to calculate this, we find the displacement over the time interval. So here, my starting position is point A, my ending position is point A. So x2 is negative 5 meters, that's where I ended at, minus my starting position, which is negative 5 meters, divided by 18 seconds. But if we look at the numerator, since point A is both my starting position and my ending position, that gives me a displacement of 0, which means that my average velocity is 0 meters per second. Again, sometimes people say, well, wait a second, how can it be 0 meters per second? You were moving, you went to C, then to D, then to A. How can you have an average velocity of 0 meters per second? But again, average velocity takes into account what direction we're traveling. So part of the time we were moving to the right towards D, part of the time we were moving to the left back towards A. And when you average all those things together, I ended up where I started. So on average, I didn't go anywhere. Again, I might have moved around in this, but this average velocity only depends on displacement. So I only care about my starting and ending positions. Anytime you start and stop at the same point, the displacement is 0, which also means that the average velocity is 0. This next problem is another type of average speed problem. This is something where you can be given the distance that you travel at one speed and the distance you travel at another speed, or the time you travel at one speed and the time you travel at another speed, and from these you can calculate the average speed. Sometimes people want to just take the two speeds, add them together, and divide by 2. Just find a simple average of them. But you can't do that because you're not spending the same amount of time at those speeds. It's something called a weighted average. And the way I like to explain it is if you were taking 10 quizzes in a quarter, and you got, on 9 of them, you got 100%, and on 1 of them, you got 50%, you'd be very mad if your teacher gave you a quiz average of a 75%. And he would say, oh, well, you had 100% and 50%, and so those average out to 75. And you would say, well, no, I had 9 100% and 1 50%, and so my quiz average should be a lot higher. That's because you understand the idea of a weighted average. The fact that there are 9 100% affect the average a lot more than the 1 50%. So this same thing is true when we're looking at average speeds. The more time you spend at one speed, the more it affects the average. But the nice thing is you don't need to know how to do a weighted average. We just need to know our definition of average speed. And it's distance divided by time. So for these motions, we need to figure out how far did the object travel and how much time did it take. So in this first part, when you walk 60 meters at 3 meters per second and 140 meters at 7 meters per second along a straight track, if I draw this out, in this first part, I went 60 meters. In this second part, I went 140 meters. So from that, I can see that the total distance that I traveled is 200 meters. But I need to know how much time it took. I need to know the time that it took for this first part, and I need to know the time that it took for the second part. And so if speed is distance divided by time, time is the distance traveled divided by the speed. So T1 is the distance traveled in part 1, 60 meters, divided by the speed during part 1, which is 3 meters per second, which gives 20 seconds. The time for part 2 is the distance traveled in part 2, 140 meters, divided by the speed in part 2, which was 7 meters per second, which is also 20 seconds. And so when I solve this, my average speed will be the total distance of 200 meters divided by the total time of 40 seconds, which will be 5 meters per second. Now, some people might say, well, wait a second, you said it wasn't going to be a simple average between those two numbers. For this, it happened that you walked for the same amount of time that you ran. Both of the times were 20 seconds, which means that you spent half as much, half the time at one and half the time at the other. That's why it happened to work out to be this simple average. But this is the way that you need to calculate it. You don't automatically know that those times are going to come out to be the same. In general, they aren't. And so you need to calculate that to be able to figure out what the average speed is. For this second part, you walk for 60 seconds at 2 meters per second. So for this first segment, we don't know how far we went, but we know that the time for the first segment was 60 seconds. And then we run for 30 seconds at 6 meters per second. So again, we know that this part is 30 seconds. And we need these distances. So again, speed is distance divided by time. So again, I have that relationship. So if I rearrange that, I have that the distance traveled equals the speed times the time. So if I'm trying to calculate distance 1, it's going to be the speed from part 1, 2 meters per second, times 60 seconds, which is 120 meters. My distance traveled in part 2 is my speed for part 2, 6 meters per second, times the 30 seconds I was traveling, which is 180 meters. So my average speed will be the total distance, 180 plus 120, which is 300 meters, divided by the time of 90 seconds. And that gives me an average speed of 3.333 meters per second. Again, this could be done with any number of parts. You could have something where you walked 60 meters at 3 meters per second, ran 140 meters at 7 meters per second, then jogged 200 meters at 4 meters per second, then stood still for 25 seconds. You could keep going through and you would add up all of the distances and you would add up all of the times, including the time that you were standing still, because that's part of the total trip. And you could use those to calculate the average speed of the trip. In this problem, we have a dog that gets away from its owner and takes off and runs 50 meters away to the end of the street in a time of 25 seconds. It then turns around and comes back 20 meters in an additional 5 seconds. And we're going to make away from the owner to the right as the positive x direction. And we're going to calculate the average speed and the average velocity for this trip. So if I set this up, I will have the dog starting at a position 0. And then he takes off and runs to the end of the street, which is 50 meters away. He then runs 20 meters back towards his owner, which means that he's gone from a position of 50 meters back to a position of 30 meters. And that took an additional 5 seconds. So as we look at this, when he started at x equals 0, the stopwatch read 0 seconds. When he reached the end of the street, it took 25 seconds. So the stopwatch reads 25 seconds. And then when he runs back, it takes an additional 5 seconds. So if the stopwatch read 25 seconds at the end of the street, the stopwatch is now going to read 30 seconds when he is at his final position. So first we're going to find the average speed for the entire trip. And to do this, we need to look at the total distance. So with this, we have him running all the way to the end of the street, which is 50 meters, and then he comes back an additional 20 meters. And so looking at that, my total distance traveled is 50 meters plus 20 meters, which is 70 meters. And we're dividing by the time of 30 seconds. Again, the average speed is the distance traveled, the total distance traveled, divided by the time. And so if I calculate this, 70 divided by 30 is 2.333 meters per second. If I want to calculate the average velocity, I need to look at my starting position, which is 0 meters, and I need to look at my ending position, which is 30 meters. I don't care where he went in between. Also, I need, for my time interval, I need to use my stopwatch reading at the beginning, 0 seconds, and my stopwatch reading at the end, 30 seconds. So to calculate this, my average velocity would be x2 minus x1 divided by t2 minus t1. So it was 30 meters minus 0 meters divided by 30 seconds minus 0 seconds. This gives an average velocity of 1 meter per second. Again, the fact that it's positive, the positive sign is implied. With average velocity, I like to put it in because this means that he moved to the right, or he moved in the positive x direction at 1 meter per second. Again, on average. A common mistake that people will make with a problem like this is they look at the equation for average velocity, they see that it says t2 minus t1, they look at the question and they say, oh, I have 2 times given in there. I have 25 seconds and I have 5 seconds. They say, oh, well, I just have to subtract those 2 times. Those times that are in the statement are not the stopwatch readings. You need to think about what the stopwatch reads at the different positions. At the end, the time is 30 seconds. That 5 seconds that's given is the additional 5 seconds that's added on to the time when you were at the end of the block. For the last part, we want to find the average velocity from the end of the street to the final stopping point. We're only going to be looking at the end of the street when he's at a position of 50 meters to his stopping point at 30 meters. So for this, I have an average velocity x2 minus x1 divided by t2 minus t1. My later position, the stopping point, is a position of 30 meters. My starting point, the end of the street, is a position of 50 meters. And then with my times, my final time t2, that's the stopwatch reading when he is at the position of 30 meters, which is 30 seconds. But my t1 is the stopwatch reading when he is at 50 meters, which is 25 seconds. So this is 30 seconds minus 25 seconds. This is that 5 additional second interval when he ran back towards his owner. So this would be negative 20 meters divided by 5 seconds, or negative 4 meters per second. Again, the negative here means that the dog, when he was running back towards his owner, was moving in the negative x direction. So again, as you do this, we can find average velocities between any 2 points in the motion. It doesn't just have to be between the beginning and the end. You can be asked from the middle of the motion to another point. All you need to know is what position it's at and what time it was at those positions. For this last problem, we have the information given to us slightly differently. Here, we have positions and times given to us in a table. So we have the position of a Pinewood Derby car that was going down a track and was observed at various times. And so it started at a position of 0.8 meters. Notice it doesn't start at the origin. And then it moves to 3.3 meters, 10.8 meters, 23.3 meters, 40.8 meters, and 63.3 meters. One of the things that we notice is the distance that travels in each 1 second interval keeps getting bigger. This is because this Pinewood Derby car is going to be speeding up. Later, when we talk about acceleration, we're going to be talking about this Pinewood Derby car accelerating, and we're going to see how to calculate that. But here we're going to look at some basic questions with this. So the first thing that we want to find is the displacement of the car from 2 seconds to 5 seconds. So displacement is the change in position. And so we need to look at the position at 5 seconds, 63.3 meters, minus the position at 2 seconds, which is 10.8 meters. And so that gives a displacement of 52.5 meters. Again, displacement is just change in position, so we just look at the position at the times that we're given. Displacement will always be between 2 points, and often you're told what time you're at those points. The next thing that we're going to look at is the average velocity from 0 seconds to 3 seconds. So we're going to take the position at 3 seconds, 23.3 meters, minus the position at 0 seconds, 0.8 meters, and we're going to divide by the time interval of 3 seconds. Again, the t2 minus t1, that's 3 seconds minus 0 seconds. That's just giving us the length of the time interval for this average velocity. So this is an average velocity of 7.5 meters per second. Again, it's moving in the positive x direction. So it was a displacement of 22.5 meters divided by 3 seconds, which gave us this average velocity of 7.5 meters per second. Finally, we're going to look at the average velocity from 3 seconds to 5 seconds. So again, average velocity, it's x2 minus x1 divided by t2 minus t1. So we need the position at 5 seconds and the position at 3 seconds. So at 5 seconds, it's 63.3 meters. And at 3 seconds, it's 23.3 meters. And the time interval is 5 seconds minus 3 seconds. So if we look at this, this is a 2-second long interval. So we have a displacement of 40 meters divided by a time of 2 seconds. This gives an average velocity of positive 20 meters per second. Again, this car is speeding up as it goes, so the average velocity from 0 to 3 seconds is smaller than the average velocity from 3 till 5 seconds, which agrees with the fact that this car is speeding up. Again, there's a lot of different ways of doing average speed and average velocity problems, but these are some of the most common types of problems. These are important ones to know. And again, in each of them, there's a little bit of a difference, and so make sure that you understand all of the different pieces to be able to solve all of these problems. I hope you enjoyed calculating average speeds and average velocities, and hopefully through these videos you find that physics is fun and you come to enjoy things a little bit more.